Okay, let's look at some of the example homework problems in 16.3. Number 12 is the first one. The region is D. And in D, y is between 0 and 1, and x is between 0 and y. So if you graph that, this is D. So let's try it this way, setting it up. Vertically, we would go from x to 1 with respect to y, and then we would go from 0 to 1 with respect to x. Now we can't integrate that with respect to y, so we're going to try going this way. And so if we go that way, we have x is going from this way, y to 0, and y goes from 0 to 1. And the reason we can do this is because we can say u is y squared minus x squared, and du is minus 2x dx minus 1/2 du is x dx. So when I do this integration, I'm integrating minus 1/2 u to the 1/2 du is minus 1/2 u to the 3/2 2/3, which is minus 1/3 u to the 3/2. Okay, plus constant. Well, let's go back and substitute in I could write it like that, but I'm not going to. Okay, so I'm integrating that from 0 to y, so I'm going to evaluate that. X is from 0 to y. So if I plug y in for x, I get 0. And if I plug 0 in, I get y squared. So that's going to be 1/3 y cubed. Then I'm going to integrate 0 to 1 with respect to y, and that's 1/12 y to the 4th, 0 to 1, which is 1/12. Okay, so you see in this example, one way to integrate is easier than the other way. In 16, I have xy squared, and d is x equals 0, and x equals square root of 1 minus y squared, which is a half circle. Here x is positive, so I get the circle radius 1. It's bounded by the y-axis in that half circle. Okay, so if I integrate over that, let's go this way. Let's see. Let's go the other way. Because this would be you'd have to solve for y, and you would get the square root of 1 minus x squared to negative square root 1 minus x squared xy squared dy, and then you would go from -1, or you would go from 0 to 1 dx. That would be the same as going this way. So we're going to go from square root of 1 minus y squared is 0 dx, and then go from -1 to 1 dy. And you could do it the top way, but you're going to have that y cubed. When you integrate with respect to y first, you're going to have a y cubed over 3, and then you have all those square roots to deal with. So I think that'll be a little harder. Let's do it this way. So first I'm going to integrate with respect to x. So I get x squared 1/2 x squared y squared is constant. So that's going to be 1/2. See, when you plug a square root in there for x, it's going to disappear, so that makes it easier right off the bat. Minus 0, so I have 1/2 y squared minus y to the 4th. Then I'm going to integrate that from -1 to 1. Okay, there's the final answer. So again, it was easier to plug a square root into something that was squared. Then here, where the y was cubed, it would be harder to plug that square root in, but you could still do it the way in the red, but it's easier to do it the way in the blue. So you may want to check both orders of integration. Okay, 24 is bounded by the plane z equal x, y equal x plus y equal 2, and z equals 0. So when we graph that, we have the line y equal 2 minus x from here, and then we have y equal x from here, and so we have this region here, that's R. So we're going to integrate over that. They intersect at 1, and we're going to go up and down. If you go sideways, if you go horizontally, you're going to have to switch it, because here the top is this function, but once you get past this point, the top switches to that function. So we're going to go up and down. So we're going to integrate from 2 minus x to 2 minus x. And here the function is z equal x, so we're just integrating x dy, and then we're going to go from 0 to 1 because they intersect at 1 dx. So that's easy to integrate. That's really easy. I'm going to leave that up to you. Just set that up. Okay, if y squared plus z squared equal 4, that means z is plus or minus square root of 4 minus y squared. And that says that y has to be between minus 2, plus 2, and negative 2. And the other boundaries are x equal 2y, x equals 0, and z equals 0 in the first octant. So if it's in the first octant, the z is positive, so we'll take the positive square root. So we're integrating square root of 4 minus y squared. Okay, let's do y first. Y is going to go from 0. Oh, well, let's draw this. That's y equal x over 2. And this is going to be y equal to. Y can't be bigger than 2. So we have this region here. And we're going to go this way with it. So y, we're going to go from 2 to, from x over 2 to 2 dy. And then we're going to go to where they intersect. And that's at 4. Because x over 2 equals 2, x equals 4. So we're going to go from 0 to 4. Okay, we could also do it the other way, so let me just set it up the other way. Let me do that one in blue. If we go this way, then we're going to integrate 2y to 0, and then 0 to 2, because their point of intersection is 4 to 2. So 0 to 2. This is a dx. All right, so that's one way. And the other way, this is going to be dx dy. That's going to give you the same answer. I'm not going to do the integration here because that's pretty simple. You can see which way is easier to do. If first, right here in the red, if I integrate with respect to y, that's going to be really hard because I have the square root of 4 minus y squared. I can't really do it this way. So we're going to not do it this way. When you integrate that with respect to x, you just get x square root of 4 minus y squared because all that's a constant. So you just have to get an x when you integrate. So this way is much easier to do. So I'll let you integrate that. Okay. I think, let's see, 32 or 34, I'm going to use maple. So let me set it up first. I have 2x squared plus y squared, and I have 8 minus x squared minus 2y squared. Now, let's see, 34. Inside x squared plus y squared equal 1. So this is a circle radius 1. So I have x is between 1 and minus 1, and y is between 1 and minus 1. So we have to choose which one of these are smaller or larger. So if x is a half and y is a half, you're inside the circle. So the first one, let's call that z1. z1 is going to be a half plus a fourth, that's 3/4 at that point, and z2 is going to be 8 minus a fourth minus a half. Well, that's 7 1/4. z2 is larger. So when you subtract, z2 is going to be first, because you have to go the larger function minus the smaller function. Okay, and if we do with respect to y first, we're going to go from, we're going to go this way. So we have y equal, no, I'm sorry, that's not true. We're going to go the other way. We're going to go this way. So y equals the square root of negative 1 minus square root of x to 1 minus x squared. That's y equals, so that's dy. And then dx is going to go from negative 1 to 1. If we go the other way on this circle, horizontally, we're going to go from, and that's going to be z2 minus z1. So we're going to go from that function, which is x equals square root of 1 minus y squared, x equals square root of 1 minus y squared, and then again we're going to go on the y-axis from -1 to 1 dy. Now I'm going to do this in Maple. So going to Maple, open it up. Okay, I'm going to go right to the integral command. I want to integrate. I don't need any special package for this. 8 minus x squared minus 2 times y squared minus 2 times x squared plus y squared from 2. Okay, so first I'm going to integrate with respect to x, and then I'm going to integrate that with respect to y. I get 13 pi over 2. I'm going to do the same thing then with respect to x first, or with I'm just going to reverse the order of integration. And now I'm going to do it with respect to y first. So with respect to y first, then I'm going to integrate that with respect to x. I should get the same answer, and I do. So we can get an answer easily using Maple. And it says find the exact volume, so that is the exact answer. If we change pi to 3.14, then that will be an approximate answer. So there, that gives us the exact answer using Maple. Okay, let's go back to our problems. I'm going to look at number 40. Forty says integrate 0 to 3, 0 square root of 9 minus y. I want to change the order of integration. So first, I'm letting x go between square root of 9 minus y and 0. So that's telling us that x squared is 9 minus y, or y is 9 minus x squared. And that is a parabola. And then y went from 0 to 3. 0 to 3. So I went this way first. It's this is my region. Now if I take that and go this way, I have to break up the integral because here the top and the bottom switch. Here it's a line, but here it's a line, and then it switches to a parabola. And where they intersect, that point right here is where y is 3, and when y is 3, if you solve this equation here, x is the square root of 6. So I'm going to go from here to here. First off, the top is 3, the bottom is 0. And then the x values are going to go from 0 to the square root of 6. Then, okay, that's this part. Then I have to go from here to here. So I'm going to go from the top is the parabola. 9 minus x squared to the bottom is 0. So the top is the parabola right here. And then I'm going to go from the square root of 6 to this point right here, which is 3, 0. So to 3 to finish it off. dy dx. Okay, so that's what you get if you switch the order. Now the first way is easier to integrate. This is going to be harder because you have to break it up into two integrals because the top and the bottom functions switch. Okay, 44. I'm going to just switch it. So you can't integrate this. You can't integrate the square root of x cubed plus 1. So when we switch it, first off, the picture's going to look like this. I'm going from the square root of y to 1. So I'm going this way. And now I want to go this way. So I'm going to integrate x squared to 0 with respect to y. And then I'm going to go from here to here, which is 0 to 1 with respect to x. So that's really easy to integrate with respect to y because that's a constant. So the integral is just add a y to it. And then integrate that from 0 to x squared. Evaluate that where y is 0 to x squared. And then go on from there. So this is hard, or you can't integrate it. You have to use Maple to integrate it. Whereas if I switch the order of integration, it makes it a lot easier. Okay, I hope this helps when you try your problem.